We're going to talk about overcoming HVAC system redesign challenges. I think any of us that have done this would agree that getting started is the hardest part. And it's like once you hit that first obstacle, that first bump, for many companies, it just is insurmountable. A lot of these experts, as I'll call them, have overcome a lot of those obstacles. So now is your opportunity to bounce a whole lot of ideas off of them, gain from their experience. You'll notice that the expertise is across a wide variety. Contractors, design specialists. So there's a lot of wisdom up on this stage. As a matter of fact, I feel it kind of pushing me off to the side. If you guys would, we've got mics around. If y'all would, just introduce yourselves. Let them know your background, who you're with, for those that may not know you all. Alex, you want to start?
Sure. I'm Alex Meaney, founder or owner or whatever they want to call it of Mean HVAC. I used to be the Wright soft guy. Worked for them for close to 20 years and recently went out on my own in 2022. I think I'm still kind of the Wright soft guy. That's mostly what I do is teach people how to do HVAC design using software. But I've got a lot of side projects going on, mostly with the ACCA, and do whatever kind of consulting, design work, things like that. However I can help people, let me know.
My name's Ed Janowiak, and I work for ACCA. I'm sort of the book guy compared to my twin over here, Alex. And I talk about the design series a lot. I'm the manager of design education there. I'm a heating and air conditioning guy. I spent 15 years in a service truck before I showed up for a class where the guy who was supposed to teach it didn't. They asked me if I could do it. Harry asked one of the attendees, how did Ed do? And I quote, well, Harry, it didn't suck. And my kid's 26 years old, and that was 26 years ago. So I've been talking in front of people about stuff that I kind of understand for quite a while, and I enjoy it.
I'm Brian Wright with Crossway Mechanical out of Houston, Texas. HVAC contractor, 29 years in the business. Started Crossway Mechanical 14 years ago. Been in the retrofit replacement pretty much since I got started in the business. So it's what we do. Mainly is just retrofit replacement and hands-on. Did installs for most of my work for up to 20 years in the business. And then the last few years, just I would say really running the business and having built a team of people to help get these jobs executed and stuff. So but that's Crossway Mechanical.
Well, good morning. My name is, when I get nervous, I use a script. Paul G. Wieboldt, Tradewinds Appropriate Technologies, Waco, Texas. Okay, got that out of the way. I started an AC business in Central Texas in 1993. I started another AC business and ran them both in 1999 called Tradewinds Appropriate Technologies, which also was alternative energy and all kinds of things. I found out right away that nobody was ready to go off the grid. They had to shrink their energy footprint. So I set out for the next bunch of years to help people reduce their energy footprint rather than try to have them go completely into a log cabin with a well pump outside and an outhouse. And I wasn't in Kentucky, so it wasn't going to work well.
That's the norm there.
Yeah. So I have a company called Manual J Design Studio. We do design work and training all over the country, Zoom training. My mentor, when I started out, told me I needed to do a heat load on every home, and I did thousands that nobody ever used, but I got lots of practice.
My name's Dawn Mroczak with GV's Heating and Cooling. We're based out just north of Chicago. I am second generation, so mom and dad started the business in 1990. I've been in the trades for about 20 years. I pretty much started ground up from sweeping floors, inventory, to marketing, accounting, and now then sales, and now I'm kind of doing like the general manager position. Majority of our work is just equipment replacements, a lot of duct renovations, air upgrades, returns in basements, and then some obviously on the supply end if you're fixing the return. Hard to come find out, but you have to obviously do the supply as well. So a lot of ours is just equipment replacements on residential.
Nice. Thank you all for the introductions. One of the things that, as you can gain, we got a lot of experience up here and expertise. With that comes a lot of lessons. And I think for the first question, I know that would be on my mind is, for all of you, what is one thing that you wish you knew before you started redesigning HVAC systems in existing buildings and homes? What's just the one thing for those who might be getting started that you wish you knew? And we'll open it up to the panel.
I'm not shy, so I always got something to say. I actually was up about 2 a.m. this morning because I'm an old guy and I sleep for 4 hours and I'm up for 2 hours. And I realized that I was doing this today, not tomorrow. So I went through the script of questions and looked at it. And I was forced into being a guy that had to deal with the homeowners before I can honestly say I understood how an HVAC system really worked. And what I learned later was that if you can apply math to it, meaning you can measure the airflow, you can measure a temperature rise or a temperature drop, and more important, get your enthalpy change, you can determine if a system is really doing what it's supposed to, and we can determine if it's a house problem or an equipment problem. And I worked for a guy named Andy, and he used to say, sometimes you eat the bear and sometimes the bear eats you, but don't get eaten too much. And I got eaten a lot when I was learning how to do this, because you get into that whole idea of, I got to do it cheaper. And you don't. Because if you are good at what you do and you can tell somebody what you're going to do and you do it, it will eventually come. So it's a long way to say that if I understood really the fundamentals of how stuff really worked, I think it would have aided me greatly in those first couple of years.
Awesome. Thank you, Ed. Anyone else? Alex? And Paul?
Okay, I wish I understood that nobody had ever done a manual J on any house I ever went to before I got there. That I wasn't redesigning anything, I was designing it for the first time. The inmates were running the asylum, and it took me a while to catch on, and not everybody was committed to the due diligence that I was applying. That was a real aha moment. But then I also realized that everybody has an opinion about how to size equipment. And I was the guy bringing the data to the gunfight. And I was going to win every time. The other piece that I'll give this credit to a guy named Kelly Parker, who's an engineer out of Oklahoma. I was at a meeting one time and he told me, you know, I charge for my load calculations. I said, you do what? It's not a free estimate? He said, oh, it's engineering. You ever meet an engineer that would give you a free estimate? They don't do that. He said, I charged 10 cents a square foot. I went home. We canceled everything we were doing and we sat down and figured it out. And we started charging 10 cents a square foot for doing load calculations. My son's closing rate went up to 90% because the people that didn't want to load calc want our customers anyway. So they refused the first design fee and then we walked away. When we gave them a design fee, we gave them the fee and they paid for it, we found out it was a down payment. We didn't call it a down payment. We said, you can have the results of this and put it out for bid to anybody. But 90% of them said, well, if you're the only one bringing a design, everybody else is afraid to do what you applied there in that solution, that prescription, and we're not touching it. So we got the job. I wish I'd known that. I'd done a lot of load calcs for free before I learned that.
First of all, I love that advice. That's awesome. And if anybody doesn't feel comfortable doing that, I'm a big proponent of not sharing design information in a quote, right? If you want to give a free estimate, you can give a free estimate. You're not going to give a free estimate and a design away, right? It fails to establish the value of what you provide. If you want to be able to play in that ball game and not, if you don't think your market can support charging money for it, my favorite phrase, oh, don't worry, anybody you hire should be able to do this for you, right? Don't treat, if you're going to be the person who designs things and is data-driven, is doing the job right, that's not what makes you better than your competition. It's the minimum that qualifies you to work on that house, right? You're just barely clearing the bar by doing this. It's an excellent, excellent way to establish value, right? I think I would probably say that the one piece of advice, code is whatever they were enforcing that day, right? Early on in my career, I made a lot of assumptions about the way a house was built because of the way the house was supposed to be built. I don't care what the code book says. What did they let them get away with, right? If you're not measuring, you're guessing. If you think, it's not a guess because it was in the code book when they built that, you're going to be sorely mistaken.
Great point. Anyone else? No? Okay. Another thing, we talked about it, there's sometimes, and I'm sure you all have seen this, that you go into a house and the house just beats you. You're very limited on the options that you can have. Those challenges present opportunities. And one of the things that I think the panel has faced is a lot of those challenges. And one of the things I'd like to find out from you guys is, what is the toughest challenge that you faced redesigning an HVAC system? And how'd you overcome it? There's a lot of them. Paul was quick to grab the mic on that one.
Yeah, I'll give you the 30,000-foot level view of the 20,000 square foot disaster that I had to redesign. How's that? One of the richest guys in Texas was building a house. It took 4 years to build and 2 years to fix it before he moved in. The floors were warping on the 4th floor from humidity. The great big dome, the rotunda in his entrance was raining. He had indoor weather like the Houston Astrodome. And a very professional company with a very professional name that sounded like their brand was like the best, most excellent, highest pinnacle contractor in the world had loaded the design with 75 people in this room and 50 people over here. I forget, they had 75 tons in the house or something. And it was raining. And I was hired to go in and redesign the whole thing after it was built. It was geothermal, so the piping ran through all kinds of places. And I had to work with the existing contractor. And so I did several iterations, tested, made recommendations, gave him a plan. $56,000 of consulting fees later, they still didn't get it right, even though I did it in crayon with them to show them how fundamentally everything needed to be changed. And they had a really slick way of not doing what they were told, but making themselves look busy. Like, the government pretends to pay you and you pretend to work. You've heard that one? And so ultimately, we did get the place comfortable and the floors laid back down. The inlaid wooden floors started laying back down. You couldn't roll a marble down the hallway without it hop, skipping, and jumping. And they were able to move in, and several years later, they replaced everything. That was a challenge, trying to work with the original guy who was so confident that he could never be wrong, and he had faked his load calc so slickly that it took me hours to figure out where he hid all his hidden loads. It was sensible loads that were latent. How about that? They hid their internal building loads in the calculation in ways that were like under the rug. So they beefed up sensible by adding people and sensible internal loads. So that's hidden loads in a load calc. So they faked it.
I would say some of the toughest challenges that we face, that we've come against is elevations of roofing. A lot of our work is done in attics. And I've seen over the years, when I first got into business in the early 90s, we had great big attics. We had a lot of room to do things. And then that's like a lot of the ceiling heights in those houses back then were like 8 foot. Then they started going to 9 foot. Now we have 12, 14 foot ceilings, and then we only have like 3 foot of attic space. And I would say that's probably some of the hardest challenges with designing a system that's can fit in that type of attic with the volume that we have with ductwork and everything to get it done right. So I would say with architects and the aesthetics, I think so many people are more concerned about having a closet space and more higher ceilings. So over the years, I've seen challenges with just smaller attics and the ventilation being a big challenge for us in our region.
and I'm actually going to keep this one brief, and you know how hard that is for me. The biggest challenge is dealing with consumers that want us to bend physics. It's literally it. There's times where we have to there's times we have to run away from people. I want ink on contracts, I want checks, but I want to run away from potential problems. And I personally think that in a very short period of time, you can understand that that person wants something that you can't provide, and don't try and provide it by throwing capacity at them.
Well, I want to go back to the whole attic situation. Just because you see like an upflow furnace or even like in a crawl space, right, can always turn that into horizontal. So like we ran into that situation where if you don't have the height room, you have to be creative sometimes, right? Where you turn it horizontally, do some blowout fittings. We had a situation where there was so much air leakage on the return end where we opened up that the attic access, and my hair was legit blowing because there was so much duct leakage. So the biggest thing, same thing like in attic situations, is just be creative. Even in basements, like if you have to turn it horizontally, I mean, you have that situation too.
Excellent. Al? No, Alex.
No, I was basically going to say what Ed said. The hardest thing, because I don't take on a lot of redesign work myself. I help folks like you guys do the redesign work. And especially from my position, I always felt pressure not to tell people no, right? Like, just no, you can't do that. Like, we've hit a line. You're not arguing with me anymore. You're arguing with the laws of physics. No, right? There's probably a little gray area there where people will ask you for things that they think they want, and it can be worthwhile to have a deeper conversation with them to find out what they actually want, right? Like the number of homeowners you talk to who tell you they want it to be 68 degrees in their house, what they probably want is it for to be 50% relative humidity in their house. And they don't know how to do that except to turn their thermostat down to 68 degrees to achieve comfort. Sometimes you have to read between the lines and do a little educating, which is difficult to be sure. But at a certain point, there is definitely a, nope, sorry, gotta go, walk away.
Excellent advice, you all. There's a common misconception in our industry that to redesign a system, you have to rip out everything that is existing and start over from scratch. And while that may be valid in many situations, oftentimes it's not. One of the things that I would like to ask the panel is, how has testing changed the way that you approach HVAC system redesign? Having the data. Oh, we got a question? Yes, we didn't have to wait. Terry, please.
Service. Going back to, Brian's thing, I'm in that same market where we run across those situations, and, sometimes, we want to be the solution provider, and we, go to provide that solution. We don't say no. So what are some of the, things that you've done to get creative to, get those jobs done effectively without, turning your back on the project and everything? Because, it gets near impossible. You got equipment in between two trusses. You can't go horizontal or vertical. Like, this is where it has to be, so like, what are some little, tidbits that you can give us on, creativity in those moments?
Yeah. So there's a lot of projects that we've done, and after joining NCI and learning a lot more about things, we work with contractors, and a lot of the clientele that we deal with don't really mind when you can present a designed and engineered solution for their home. They're open-minded to it. So we've actually incorporated closets, or we've had to make some extra room and different things, especially like chases to get to the first floor to get the airflow right. We've taken out closet spaces. So, sometimes we might have to have like a handyman or some type of contractor come in and reinforce something or give us a little bit more space for things to make that system work. Because a lot of people are starting to be more educated on the importance of the lungs of the home and the HVAC system, the important role that it plays. And the awareness, I think, since COVID has made more people realize the importance of having a properly designed system, so, but sometimes it's just a matter of having some construction work done, or we have a lot of supports in those attics too, and you can't just go cut supports because it's, it has, that's what supports a roof, right? So you could be responsible for that, but we'll have someone come in and look at that and maybe make some more room for us to get some supports out of the way. And so we've done that quite a few times, just to make some space but even learning through NCI, I mean, we've done some really crazy offsets, to get the air moving. So if we don't have room for a 6-foot plenum or, because of the space, we'll go up and use a 45 or radius and go up and then, straighten out anywhere else that we can. So, I mean, we've had to get creative lately with some of the stuff that we've done.
Excellent.
I would also add that I'm a big fan of like radical honesty in sales. And when you're in that situation and you find yourself wanting to say no, rather than just saying no, you can say no and then ask your homeowner to think about this. I'm turning down your money, right? You're offering to pay me and I'm saying, I'm not going to take your money. It's not going to work. This is how much I believe we can't do this. Is I have mouths to feed and payments to make, and you are offering me what I need to do that, and I'm turning it down. So you can probably go out and find somebody to do this, and you're going to end up calling me back. And it's, I don't want to see that happen to you, but I don't want to go down this painful road with you. And you would think a homeowner had already connected those dots. No one's ever gone broke underestimating homeowners, guys. It's surprising the dots that they won't connect. So sometimes maybe you got to help them do that.
Paul?
The question's on testing.
It's unless you have something to add to Terry's response. The question was on testing. How does testing change the way that you approach
I'm
redesign?
just chomping at the bit to answer that question.
Take off.
Okay. So on testing, I found testing my design is a confidence builder. It's like you build a paper airplane, you try to fly it. It looks pretty on the table when you're doing your origami, and only certain ones fly. Testing is what proves your assumptions. And so when I first tested, the very first job I tested, I keep referring to this guy was one of the richest guys in Texas. This was another very rich guy in Texas. And we're at the ranch hand's home, or the ranch managers that were building him a new home. I had just gone to NCI testing, came back with all my new tools. They didn't have any stains or pookie on them or anything. And I walked into the job and I tested for the first time my manual J, D, and S design in a real world application. And we scored 96%. And I was elated because I was able to prove my due diligence was provable by measurement. And what really blew my mind was my lead installer came to me and didn't ask, how does it look? He said, how did I do? And I realized this is a positive feedback loop for the craftsman, and I'm trying to develop in my business. And he was asking, what I did I fail or did I succeed based upon knowable measurements? It changed our whole way of looking at our business.
What I call that is getting predictable results. If you do math up front, you can prove it on the back end with the math. But to go back to your original questions, I like the idea on an existing home that in literally 2 or 3 minutes with some strategically placed static pressure tips or a skinny piece of copper, if we're looking for some ballpark kind of stuff, you need to absolutely know that big numbers aren't always bad and little numbers aren't always good. They're going to be comparable to something. And once you get to the point where you can identify that those little numbers are good, and it's because everything is clean inside, that can give you guidance on what this system may or may not need. The same way you can have big numbers, and I'm in the basement metal duct furnace coil market predominantly. It's not unusual for me to see big numbers, and a big number is a 0.5 in the return. If that fan has enough oomph, I've got a 4-ton drive and a 2.5-ton air conditioner. It's going to work. So you can't automatically assume that bad numbers are always bad, because they're not. So to follow that up in the appropriate place, I think you might find some place today where somebody can help you if you're not 100% sure what those numbers mean.
Testing for Crossway, after attending NCI classes and learning duct design and duct optimization, we started implementing the testing on all projects and service calls and stuff. After the first probably month of learning it, kind of putting a plan together, it changed how we did a lot of things. We stopped focusing on sales and started focusing on solutions. And so it gave us, the testing helped us really implement stuff to realizing that like you don't have to do a full system replacement. You can do, return air upgrades or fix ductwork or support it, strap it, seal it. There's other things that we started doing. So it just changed the way that we started, and it started generating work, and we started staying busier. And then in the slow times, like normally in Thanksgiving, Christmas, on that area, we were busy doing duct replacement or duct renovations and stuff. So testing changed our bottom line. And it's just through the measurements, having the data, and being able to have an educated conversation with the homeowner about it started, that's the path that we've been on for the last few years, and it's made a big impact on us.
So same for us. I would say with the testing, we pretty much have no slow season. So in the slower for Chicago area, be like you're in between seasons. So like in December, January, February, maybe some March, where you'd be slow, that's when we're doing all of our duct renovations and air upgrades. That way we keep our guys busy.
Very good. Alex?
Yeah, just piggybacking a little bit off of what Paul was saying. Testing is awesome for doing deep thinking, but exposing yourself to as many good data points as possible is an amazing way to build your quick thinking, right? The human brain is amazing at pattern recognition. All it takes is for you to see enough to start to identify those patterns, right? Like we would rather you learn how to do the math and think about these data points and be taught, A plus B equals C. But man, if you just saw A plus B 100,000 times, you'd know it equals C without anybody having to tell you. Literally just exposing yourself to some good data points will help build that quick thinking part of your brain. It is super, super valuable.
Excellent. At this point, what I'd like to do is you're going to notice there's roving microphones around. If you guys have questions, throw your hands up and let's see what the panel has to say. We've got quite a few.
Yeah, we do.
All right. Okay. So testing is obviously a really
Hello,
beautiful
my
art,
question
and
is-
implementing has been amazing. As Brian said, it's provided, it's changed our bottom line. But as the demands for calls increases, and it looks like they're only going to increase, how have you guys met the challenge of still doing the same amount of rigorous testing and also meeting demands for calls? Has it been a matter of simply hiring and training more personnel, or picking and choosing what are the most essential data points to take on each call? How have you guys met the challenge?
Yeah, we're crisis management contractors. And when the peak load is there, we can't meet the demand. So making a study with getting all the world's data points that are available on the psychometric chart is not something we can do. But at least we know that we can capture data by getting static pressure and other telltale signs of an ill system. We can log that and leave the customer with an impact statement that says, your system is not healthy. We can do an emergency repair. But right now we have 7 other people waiting for the same kind of emergency relief. So would it be okay if we could come back and do a deeper dive or analysis, or, test your house to see why you're losing equipment and having failures? So we can defer to times where we can manage, or maybe we have a designated guru with the tools that'll come back that's not my best diagnostic technician that fixes or replaces the parts to keep going. So the emergency room doctor, maybe, and then the specialist for referrals. We found that to work very well, that it doesn't have to be done now, but we have to get enough data to justify coming back.
I think too, finding the sweet spot, like more calls equals more money is not necessarily going to be true, right? You want to maximize the dollars per call, but between every call, there's a dead zone of drive time where you're making $0. You're losing money, you're losing gas money, you're losing time and labor. And so I think the goal, and this is probably going to be a little different depending on the market, but I think the goal is to allow to use that, or allow to use that testing to support deepening those dollars, right? Because you'll go to some of these sales meetings and it's like everybody ought to sell like a capacitor and a contactor on every single, like, that's bullshit. I mean, if they don't need it, don't sell it to them. But identify what they need, right? Like the spirit of that's right. If you want to make money, you should be, while you're there, you should be maximizing what you sell them. If you can do that by identifying what they actually need, not only is it easier to sell because, here we use tools, right? Homeowners don't know, one guy from the next, whether you know what you're talking about or the other guy knows what you're talking about, but they know you use some tools, right? You measured some things, you wrote them down, right? Like that makes the job so much easier to add things to the ticket and sell things. And you can sleep well at night knowing the things that you sold were things that they actually needed. So yeah, I don't think running more calls is like a great goal. I think maximizing your calls is a better one.
Anyone else?
Hey, back here first.
My question is, when you're doing a duct redesign, do you have to, say your supply boots here in the floor or in the ceiling, do you have to remove all those and put new flooring down, repatch the ceiling if you're doing a duct redesign? And particularly that supply line shouldn't be in that particular place. Do you have to redesign it somewhere else?
It depends what the problem is, right? If you run the numbers and it looks like the amount of airflow they're getting should do the trick, it's a pretty good, pretty good bet that it has something to do with the supply grills and the throw and mixing the air in the room, right? Like, when 2 + 2 doesn't equal 4, one of those isn't a 2, right? So if you've identified that the problem isn't anything up to that point, that's where I would start to focus on it. But I'm a big fan of a concept called minimum effective dose, right? Like, let's be as least invasive as we can, least disruptive as we can. Where are we going to get the biggest bang for our buck? And that might be out there at the end where the boot is, but it's going to have a high disruption cost, right? I'd be looking at most things I could before I look at that, right? Like, let's look, do we have adequate return? Because if I can increase my total airflow, I'm going to increase the throw I have at those grills, right? So yes, that you can't really rule out anything till you've discovered what the actual problem is. But a great way to assess what the best prescription is what's going to be the cost of this, not just in like dollars, but in terms of disruption, in terms of like what, the feeling that homeowner has of like, oh, this guy is tearing my house apart. Like there's a real cost there. So maybe, but it depends on what the underlying issue is.
And I'd like to build upon that. I can count on one hand of the hundreds of redesigns that we've done where we've actually removed any hardware out of a house. But what we have done, and this gets back into those big pressures and little pressures, those big pressures are problematic. And I try and look at it from a very simplistic view. If we have a lot of pressure, how do you address it? Well, you get rid of it. So you get rid of air by doing it. And one of the questions David had written and showed us said something about doing non-traditional approaches. And I would put supply outlets in specific areas where the books that we try and follow say don't do it. In two-story houses where the second floor was a problem, I've put 36 by 12 supply outlets right at the top of the stairs at belly height because I was able to put a 10 or a 12-inch flex off the top of a plenum. Now, can they close their doors at night when it's time to go to bed? No, but they couldn't before because it was 10 degrees hotter on the second floor to begin with. But I was dumping 400, 600 CFM into a hallway, leave the bedroom doors open and maybe use a little fan or something. So for a quarter of the cost, for a tenth of the cost of actually fixing it, I was able to provide them comfort on those days of the year where they really needed it. And it gets back to that whole disruption thing. If we can create a minimum amount of disruption, the other one's going to be the heat-only systems that have 4-inch branch runs. And inevitably, there's the contractor that thinks they can run 2,000, 3,000 feet per minute through those things and the people still be able to hear the TV. So putting ducts in parallel, adding additional ducts in non-traditional locations. And my final thought is if we have a supply outlet in a bad location, you can do a lot with register selection. It's the most overlooked thing of the books that we go by. And if you can get your thumb over the end of the hose is the analogy that I use, we can get that throw and spread that stops blowing air on my head and makes the people happy and they don't have to turn the TV up when the system comes on.
Yeah, that's a great question back there. So the last couple of years, we've geared and we've turned towards doing a lot of invasive stuff to get the proper size ductwork to areas, grill boxes. So a lot of our stuff now is, and my team can tell you that are here with us, I mean, the stuff that we've gotten into is complete reduct designs on 2 and 3 story townhomes or homes. And it's ripping all the ductwork out, sizing it correctly. But we're also doing building science that we look at, mid bands and stuff that aren't sealed. So, but we do. I mean, if we have to move a grill or we have to move a register box, but we always listen to what the customer's needs are and they'll let you know. And then when you sit down with them about their budget and how much it could be, but we exclude a lot of that stuff too. So I don't do anything with the sheetrock. We let them know that there's, damage, and they'll find, so the stuff that we're involved in, we exclude a lot of the sheetrock, the painting, roof work, just for liability reasons. But homeowners, they're paying. I mean, we have quite a few projects where they want everything ripped out and want it done right, to have a healthy home. So
Say something about the 3-story place and they work. Tell them. Because it does. You can make a 3-story place work.
Yes.
If you do the math and follow the good guidance that's available to you, you can make those systems work. You just can't hope that they work. But you got to do the legwork. You got to do the math. But they work, and it's so gratifying.
But don't believe your initial manual J results when you're calculating the 3-story.
In what respect?
In what respect is the stratification of air, the communication between the levels. There's some things you have to understand about where that heat load's migrating to. And it's just, you have to have pattern recognition. There's some things going on with the science that we understand about how the building works. So I just, back to that initial question, the core of the question is, we just happen to have on our staff a licensed master plumber who had 17 years of experience as a wood flooring contractor. I have 5,000 hours as a drywall finisher and texture expert in the drywall field. So I never saw a ceiling I wasn't afraid to retexture. I wasn't afraid to cut in a new register anywhere because I knew I could patch and repair it and make it invisible. Now that's within our team, but our strategic alliance is more important. And having people that I know I can refer to, if I have to do something so major as to cut into something, I got to know I have somebody that can make it look like it never happened. If you can't do that, don't do that. Just, duplicate, put a twin register in the room. We did one job where our static pressure was, total external static pressure was 0.6. And we weren't happy with that. And we said, well, why don't we experiment? We'll just add one more run to the master bedroom that's the longest run, the longest total equivalent length. We'll add another parallel run to that, and the static pressure went down to 0.5 and we called it a day. So there's ways, we had a carpenter on our staff for years, so we would take out equipment from a closet, raise it up a foot and put in a larger return, and use turning vanes in the return on a platform unit so that we can get air to come around that 65-foot equivalent length that is what a right angle L is. A platform return is equivalent length of about 45, 65 feet. And we would just provide smooth transition on the inside, the throat of that elbow, and we can improve the performance like 30% with smoke generator, watching the patterns of the air. So there's a lot of things you can do. You just have to think outside of your immediate specialized trade, not be afraid. I try not to cut into anything if non-invasive surgery is my thing. But one more point of that, Austin Energy, you guys challenged me because I said you can fix, it's the duct stupid. And you said, okay, prove it. They gave us 17 houses to redesign the ductwork and make it work without permission to change any of the unitary equipment. We couldn't change out a condenser or an air handler, but we could modify the ductwork. There were houses that were built in the 60s and a house that was 3 years old, and we were able to improve performance by 30%. I'd say it's a fair estimate on every home without having to do any major surgery. But we did a lot of stuff with turning vanes and extended plenums and even cutting in returns down the side of a closet and using turning vanes to bring that air back into the closet, into the platform return. So they threw everything they could at us on every kind of duct renovation. We were able to improve noticeably in all of those without major surgery.
Yeah. I had even if you're going to stay in your lane, right, you're going to stay in the HVAC lane, avoid tunnel vision, right? So like my problem is there's not enough air coming out of that grill. You know, you can't supply what you don't return. I can add a return to a system and get more supply out of those grills, right? And so, yes, it's good to be solving the problem at hand, but when it comes time to figure out what those solutions are, take a step back, right? Look at the whole lay of the land, because there are a lot of times very creative solutions that are really just built around the interconnectedness of the HVAC system in the building.
We've got one here first.
Well, my question was to Paul to remind him to talk about our study. So that's what my question was for. So you mentioned it in your breakouts, but obviously everybody can't go to your breakouts. But the other issue I want to question people on is leakage, home leakage. Point out the value to doing blower doors, isolating the ductwork on retrofit, because that's the part of Manual J we keep guessing about. We keep guessing on air tightness. And everybody knows one frame, you can actually in a subdivision track a framing crew on how well they build or they don't build with envelope leakage, with the blower door.
You're looking at me?
Yeah.
Okay, so first of all, Manual J is building science. If you can't evaluate the envelope, you can't do a proper Manual J. It's building science. It's all about the envelope. It's about heat transfer. Okay, so I have to understand the envelope and the leakage with the blower door. We use infrared. We want to find out where they didn't do their due diligence with insulation, where the voids are, what the effect of R value is with the voids in the attic, all of that we have to understand. And we improve that. So one, Manual J, we're talking about redesign, so that's the narrow scope of what we're trying to broadly address. And so I don't look at building science as building science in an existing home. It's forensics. I'm on a crime scene. Some serial duct killer has been here ahead of me. And I have to piece together what they did to make this thing such a disaster zone. So I'm looking at it as a forensic analyst, and I'm trying to piece together what has to change to make this work. And if my tunnel vision focuses completely on the ductwork, the refrigerant piping, the equipment outside and inside, I'm gonna miss the forest for the trees, or however that analogy works.
I want to follow up on both of these guys. Stay in your own lane, but you need access to building science. You don't have to have a blower door in your company, but you have to have somebody on retainer or somebody you can tap on the shoulder, because you can't HVAC your way out of a bad house. I didn't make that up. It's another one of those things I regurgitate, but it's very, very true. You can put a bigger unit in a house and accentuate the problem. So if that is not part of what you do, and you've ever had a system that you can't figure out why it's not conditioning the house and the occupant isn't nuts, look into the building science part of it, because you can have a house that's so bad that no matter how much capacity you throw at it, it's not even that it's going to fix it, it's going to make it worse.
Excellent. We've got, I think we've got like 4 in the back. Thank you for your patience.
Good morning. Thank you to the panel. My question is, what challenges have you had? We know the value of testing, and I like that you said, hey, we can give you an estimate, but so there's the value of what we do, our knowledge, expertise, and experience, the tools that we have, we know the value, but then there's perceived value in the customer's eyes. What challenges have you had communicating that value? Because it's not tangible. Those data points that we collect is going to allow us to come up with a solid solution to solve a problem for that customer. So what challenges have you had communicating the value of the testing and the things that we're able to do using NCI's testing methodology, some of our building science principles, and different things? Because value and perceived value are 2 completely different animals.
Please.
Yeah, all right. So like in my sales process, obviously, if you've been to my class in the prior years, I put together a form where it has like pictures and data of everything that we've collected, right? And in the past with the old Comfort Max, I would include that on all like the air diagnostic, I want to call it, calls. So that way, not only including the client in also when you're there and kind of showing them like what the blood pressure is, temperatures and everything, or even having them have the airflow hood and having them take the measurements. But with the data itself, I find it's been very helpful to create a report and kind of following up, so that way it kind of shows the pictures with arrows on what you were kind of describing. Because I feel like it's a lot of information for that client to like understand. So having that report has been very helpful for us.
Very good.
I would add to that, 1, avoid jargon, okay? Avoid the technical terminology. 2, lean real heavy on analogies, right? When you're talking to a homeowner who's not trying to learn how to do things, imperfect analogies are fine. And 3, I would suggest sort of leaning on the distrust that is inherent in the sales process, right? One of my favorite phrases for like laying the groundwork for a technical sale is when the only tool you have is a hammer, every problem looks like a nail, right? We're going to try to bring the full toolbox here. And, trust me, if you bring your car to the transmission shop, they're going to find something wrong with the transmission. You bring it to the tire shop, they're going to find something wrong with the tire shop. You bring it to the dealer, they'll find all that. And if they're good, they'll put it in a list of priorities. Don't go comparing yourself to the car dealer, by the way. Nobody likes those guys. But establishing with the homeowner that, we can bring everything to bear here, and we'll help you find what it is you actually need to fix is, and framing it around a way of like, this is why our advice is better than the next guy.
Excellent.
Yeah.
Next.
Mitch Bailey from Bailey's Heating and Air and Air Heroes. This is for Paul. Hey, Paul, on building science, that's if it's a building science guy, they always think it's the building. If it's a ductwork guy, it's always thinks it's the ductwork. how can we marry that up to where you train your techs, or you have your techs realize and do things like take pictures of attics and stuff so that they can bring it back, and then you can set up the testing? Well, how did you do that when you were running your own business?
What do you mean, were?
Still doing.
I've heard rumors here that I'm retired. I heard rumors here that I'm not teaching for NCI anymore because I'm too old. I've had gray hair since I was 39. So, but I do trim my beard at least once a month. So the question is,
The question is, how do you train your techs? How do you put that into culture of your company to where your techs are not just looking at the ductwork and not just, and are concentrating on the whole house as a system, as opposed to, how do you give that to your people in the field that when they're out there actually looking at the job? What do we do? Where do we look? How do we look at it? How do you teach your people to do that?
Take away their cell phones. You can't teach situational awareness, but you can encourage it. What did you see? I mean, FBI in their training sessions would have a guy run into the room while they were in a classroom situation, and the guy would have his tie on crooked and his, one lens out of his glasses and his hair standing up and all kinds of odd things. And he'd go take something off the desk and run out of the room, and the instructor would say, "What did you just see?" And to be aware of the details of what's happened when somebody's doing something crazy takes a certain kind of attention where you're not having tunnel vision. Is this guy gonna, what's he doing here? And so I try to encourage, well, one thing is, for example, everybody has to take static pressure. Everybody has to take measurements. Everybody on my staff would call in to me with measurements. And because of pattern recognition, if you can communicate to me on the job in numbers, what you're seeing, I can help interpret and guide and go, I can be 1,000 miles away. If you can give me good data, I can help you with your space shuttle, bring it back home. You know what I mean? So I have to have good data. So I teach guys to take good measurements, the procedures, where to take static pressure, what measurements I need to capture, and write it down so you can read your own numbers, or use your iPad or smart tablet to enter those numbers so you can read them back again and give me those numbers. That's very important. So they may not be able to diagnose, but they can capture data. So they're the lab tech or the X-ray technician. They're not the radiologist. But if they can get good pictures and help me to build that picture into a whole picture, I can help guide them. Does that help in what you're asking? So not everybody has the gifts and talents, and not everybody's BPI, HERS-Rater, and every other tag that I've tried to master in my career. But I can teach them enough to retrieve good information to me, and I'll help them to understand what it means.
Yeah, this is Derek with DNA Heating and Cooling. This question is for Ed. Ed, you mentioned earlier that you had provided a solution for a client, but in providing that solution, they had to open doors and things of that nature. With that, did you consider, or would it be a proper solution to propose passive returns in that situation? Because that's the first thing that kind of hit my brain. So I'm just kind of curious how that played out.
The story I told was about a place in Barnegat, New Jersey called Settlers Landing. And I hate when I start off like this, but it was 25, 26, 27 years ago. The way I tested for room pressurization, did you ever see The Shining? And what's his name does, "Hello, Johnny," and looks through the crack in the door? That's the way I looked for whether a room was getting pressurized or not. I maybe had a DG2 back then, and I might not have even had a digital manometer. So what you're bringing up, that would be the next step in the modern age. Go see Chris over at TEC and get a roomulator and find out that whole process to properly size it. If we're pressurizing the room by putting the air in the room, that's going to work. But in the specific example that I was using, I was dumping a whole lot of air into the hallway. So that was why we would be encouraging the air blowing into the room via the door. It wasn't a problem that could be corrected by a passive grill. I guess technically, if we pressurize the hallway enough, you could introduce air into the room, but it's why it falls under the category of a non-traditional methodology to correct an issue. But you're definitely thinking on the correct path.
What makes airflow is a hole and a pressure difference. So if we have a passive return, we have a pressure relief valve, but we really don't encourage flow. 1 CFM, 1 CFM out. Doesn't really happen unless, when you do the numbers on the undercutting of a door, if you have 160 CFM in a room, a 32-inch door needs to be cut about that. It could become a cafe door just to get the flow to return. Every room that can be isolated by a door needs a low resistance path of return. How you get there, obviously new construction, you want to be in the game in the design, but in retrofit, you just have to find ways. But you know, a jumper duct, it just provides some relief, but it doesn't make it ideal. So we have attics in Texas, so we can run returns to horizontal units in the attic, so we'll add returns to all the rooms that can be isolated by a door.
Well, unfortunately, I know there's still a lot of questions I'm sure remaining. You can track these panelists down. I guarantee you they'd be happy to ask it, but unfortunately we're out of time. So let's give it a round of applause for our panelists. Thank you all. So we've got a short break. General session's coming up. Dom, anything else we need to talk about? I'm going to guess no. We're good to go. Enjoy the rest of the day, you all. Thank you.